So yes, we're talking about colour, and so the first thing we've covered really about colour is actually quite important really, and we're looking at those opaque minerals. So a mineral that is black in plain polarized light is opaque, and those essentially it's not letting any of the polarized light through at all. Those minerals tend to be oxides or sulfides, so things like iron oxide and iron pyrite, for example, and they're quite common as, again, usually minor components of rocks, but it's worth noting them. Sometimes they can be very useful, but of course the trouble with them in petrography and a petrographic microscope is you can't tell anything much else about them. All you can look at is the shape and the fact they're black, and that's it. That's not to be confused with minerals such as garnet, which are isotropic and which are colorless or some kind of color in plain polarized light, but go black when you put the cross polars in. So let's go on to the 50 shades of grey. This is something that really you only pick up with experience. So here I've had a bit of fun with saturation on the images. So on the left-hand side here, we've got the image as I copied it from the virtual microscope. So this is essentially what we see when we look down the virtual microscope. And as you can see, most of the colours are very, very subtle. You've got a kind of white patch there. You've got a very much darker, possibly brown patch there. And then, you know, with a practiced eye, you can pick out a mineral which is pink, and a mineral which is blue, and possibly a mineral which is pale blue up here. But of course, to most people, what they're seeing is actually looking a bit like the image on the bottom right here, which I've basically almost completely desaturated. And that's what, if you like, everyone other than a petrographer sees when they look down the microscope and start talking about colour. It's just 50 shades of grey. And what you'll find is that the more slides you look at, the more you become like a petrologist, and you actually start seeing far more colours in all the minerals. The problem with that, of course, is that there are all sorts of variable factors at work, and we'll look at those as well. But in here you can see this is the same image. I've just taken it and literally just increased the saturation. And so then you can start to see that there is a sort of lilac pale blue mineral up here, that other minerals in here are sort of greenish, very, very dull greenish colour, and the garnet here comes out as very definitely pink. And then there's a blue mineral here, a sort of fringe of really quite rich blue mineral there, and even a patch of green over here, dark green there. So that's really the trick when you're looking at thin sections, particularly in plain polarized light, of course. The colours are much more vivid in cross polars. But in plain polarized light, you're looking for really, really subtle variations of colour. And those variations can be extremely subtle. So when you're looking under the on the mineral identification chart, for example, then you get these confident descriptions of staurolite as yellow, and epidote as yellow, and glaucophane as blue, and so on and so forth, and garnet as pink. Well, it's really rare to see definitely pink garnets, I think, in thin section. Some of the eclogitic garnets turn up looking pink, but it's very often it just looks grey. And so it is in this thin section here, which is stuffed full of staurolite, and this is the staurolite. So that, I think that section there is about the yellowish bit of staurolite in that thin section. But you get other bits of staurolite which are almost completely grey. So that's showing the pleochroism, the difference, the change in colour. But the other things that affect minerals' colour as well, there's things like section thickness, so that if you have a thicker section, it tends to increase or make the colours richer. Just the optics of the microscope, which has been used to take the pictures or which you're actually looking down, that can vary quite markedly, actually. And inclusions, of course, as well. So here the staurolite, for instance, is crowded with inclusions, both coarse inclusions like this opaque mineral here, and sort of paler minerals as well, maybe quartz, but also a very, very fine dusting of black graphite, probably graphite, very fine grains of graphite, and that just serves to mask the colour even further. So this is just another look at a different staurolite, and again, this is purported to be yellow. Well, I'm seeing that as a kind of tan. And so you can see that staurolite, you know, in particular, and lots of other minerals, have a very, a wide range of colours. Everyone sees them differently. So actually using colour as a diagnostic is not a particularly reliable one. And I know that it is difficult. It is difficult to get that experience which tells you that this is pink and tells you that this is pale blue and so on and so forth. It really is. There's no substitute for experience, unfortunately. But again, it's calibrating your eyes so that they are trying to pick up the subtlest variations in colour that they can, rather than expecting a wide range of colour.